Hello everyone, greetings of the day. I'm Shivani Tripathi. I'm doing my PhD from IIT Patna in the Department of Computer Science and Engineering. And today I'm going to compare some famous imbalanced data methodologies in deep learning. So let us talk about imbalanced data. What is imbalanced data? If you have spent some time in machine learning and data science, you would have definitely come across imbalanced data distribution. This is a scenario where the number of observations belonging to one class is significantly lower than those belonging to the other classes. This problem is predominant in scenarios where anomaly detection is crucial, like electricity leverage, fraudulent transactions in banks, identification of rare diseases, etc. In this situation, the predictive model developed using conventional machine learning algorithms could be biased and inaccurate. This happens because machine learning algorithms are usually designed to improve accuracy by reducing the error. Thus, they do not take into account the class distribution, proportion, or balance of classes. Now, let us talk about what is imbalanced data. If we talk roughly, we can say that imbalanced data refers to those type of data sets where the target class has an uneven distribution of observations. That is, one class label has a very high number of observations and the other has very low number of observations. Class imbalance is generally normal in classification problems, but in some cases, this imbalance is quite acute where the majority class's presence is much higher than minority class. Let us take an example of classification of emails where emails are spam mails or relevant mails. Usually the number of relevant mails is greater than the number of spam mails. So this distribution of class will result into imbalanced data set. So what we are trying to say is that whenever we take an imbalanced data and we try to train a model on it, so it is basically going to predict not so accurately according to the imbalanced data, because one class is distributed with a lot of data and the other class is distributed having a small amount of data. So this is the imbalanced data problem. So there are different methodologies in order to address this issue. So we are going to see that there are basically the first technology that is used to address the imbalanced data is resampling technique. So in today's video, what we are going to do, we are going to talk about some famous technologies in order to handle the imbalanced data. And afterwards, we are going to switch on the code and compare some popular technologies by which we are going to conquer the problem of the imbalanced data issue. Okay, so the first is resampling technique. There are four to five techniques which come under it. That is random undersampling, random oversampling, cluster-based oversampling, informed oversampling, modified synthetic minority oversampling technique, that is also known as MS mode for the imbalanced data. Second one is the algorithmic ensemble techniques. These are divided into two major classes, that is bagging-based techniques for imbalanced data and boosting-based techniques for imbalanced data, which is further divided into three more techniques. Let us now see what these techniques are actually doing and how we are handling the data imbalance. So the first technique that we refer is, and we can say a more simplified version to tackle this problem is random undersampling. So what we basically do is that we undersample the major data, the major class. So this is done. This is not such a good method to do, because we are basically reducing our data by which we are going to train our model. So in the undersampling, what we do, if suppose we have 2000 records in class A and just 100 records in class B. So we are going to undersample the majority class, that was class A, and we are going to take some 100 records from class A and leave those the rest of the records. So what is the issue of this problem? What is the issue? The issue is that we are leaving the majority of the data set, and we are not going to train our model properly because of this. Let us some other technique. Major technique that is used is random oversampling. So here what we do, we simply replicate the the underprivileged class, we can say, or we can say the class that was having lesser number of records. We copy the number of records and try to make it even to the class that has more records. Let us take an example, the previous example only, and say that the class A was having 2000 records and the class B was having uh, we can say 100 records. Then what we are going to do, we are going to replicate the 1900 records, uh, 1900 records in class B, so that it can evenly present the distribution, and we can split the training and testing data properly. But as we can see that this is also not so accurate method, because we are just copying and duplicating the data again and again. So the model is not going to be so much accurate. Let's move over the next techniques. The other techniques in these are cluster-based oversampling. Is in this case, the k-means clustering algorithm is independently applied to minority and majority class instances. This is to identify clusters in the dataset. Subsequently, each cluster is oversampled such that all clusters of the same class have an equal number of instances and all classes have the same size. So here we are using the k-means clustering algorithm. So let's see what are the advantages of this over the other techniques. The advantages is that are such as this clustering technique helps overcome the challenge between class imbalance, where the number of examples representing positive class differs from the number of examples representing a negative class. Also, it overcomes the challenges within class imbalance, where a class is composed of different subclusters, which was not happening in the oversampling, because we were just replicating the data there. Also, and each subcluster does not contain the same number of examples. The disadvantages are the main drawback of this algorithm, like most oversampling techniques, is possibility of overfitting the data, because when we are going to take the same data again and again, or we are going to take clusters also, there is a chance that we may go through the overfitting problem. Let's see another famous technique is SMORT. SMORT is an abbreviation for synthetic minority oversampling technique for imbalanced data. So let us see what is happening here. This technique is followed to avoid when exact replicas of minority instances are added to the main dataset. A subset of data is taken from the minority and then new synthetic similar instances are created. These synthetic instances are then added to original dataset. The new dataset is used as a sample to train the classification models. So here basically we are some algorithms, and we are creating some synthetic data sets in order to avoid the data imbalance, and then we try to train our model. Now see the advantages and disadvantages are like the advantages that it mitigates the problem of overfitting caused by random oversampling, as the synthetic examples are generated rather than replication of instances. Rather than replicating the instances, we are creating a new set of data which may be new for the model also. No loss of useful information is there because we are creating a new data. The disadvantages are that it is not so effective for high dimensional data. Okay. And same like mode, and it is a modified version. It does not consider the underlying distribution of minority class and latent noises in the dataset. To improve the performance of sport, a modified method mSmod is used. Into three distinctive groups. Those are security safe samples, border samples, and latest nose samples. This is done by calculating the distances among the samples of minority class and samples of training data. So the bagging based techniques for the imbalanced data. So let us talk about bagging now. Let us talk about bagging now. Bagging is an abbreviation of bootstrap aggregating. The conventional bagging algorithm involves generating indifferent bootstrap training samples with replacement, and then training the algorithm on each bootstrapped algorithm separately, and then aggregating predictions at the end. So bagging is used for reducing overfitting in order to create strong learners for generating accurate predictions. Unlike boosting, bagging allows replacement in bootstrap samples. So the advantages are that it may improve the stability and accuracy of machine learning algorithms. It reduces variance, and as I told before, that it overcomes overfitting and improves misclassification rate of the bag classifier. In noisy data environments, bagging outperforms boosting, as told before. And the disadvantage of bagging is that bagging works only if base classifiers are not bad to begin with. Bagging bad classifiers can further degrade the performance. So let's go further to boosting based techniques. So boosting based techniques are further divided into three more categories. So let's first talk about boosting. Boosting is an ensemble technique to combine weak learners to create a strong learner that can make accurate predictions. Boosting starts out when a base classifier or weak classifier that is prepared on the training data. So what are actually base or weak classifiers? The base classifiers are the weak learners. That is, the prediction accuracy is only slightly better than average. A classifier learning algorithm is said to be weak when small changes in data induce big change in classification model. So there are three techniques that are adaptive boosting, or we may say it as ADA boost techniques for the imbalanced data, gradient tree boosting techniques for the imbalanced data, the XT boost techniques for the imbalanced data. So I'll just give an overview about these three techniques, because further we have also to take the practical examples and do the things. So what is adaptive boosting? Adaptive boosting, era boost, is the first original boosting technique which creates a highly accurate prediction rule by combining many weak and inaccurate rules. Each classifier is serially trained with the goal of correctly classifying examples in every round that were incorrectly classified in the previous round. The boosting techniques for imbalanced data and gradient boosting, many models are trained sequentially. It is a numerical optimization algorithm where each model minimizes the loss function, that is y equals to ax plus b plus e, using the gradient descent method. Of course, it is based on the name only. So the decision trees are used as a weak learners in gradient boosting. So there are some disadvantages as well. The gradient boosted trees are harder to fit than random forests. Then comes the XG boost technique for imbalanced data. The XG boost, also known as the extreme gradient boosting, is an advanced and more efficient implementation of gradient boosting algorithm. The advantage is that because it is more advanced, so we can say it works 10 times faster than the normal gradient boosting, as it implements parallel processing. So whenever we are doing the parallel processing, of course, it will work somewhat better than the previous one. It is highly flexible as the users can define custom optimization objectives, and evaluation criteria has an inbuilt mechanism to handle the missing values. So the missing values are also handled. So there must not be so much inaccuracy in the data set as well. As discussed before in the video, we are going to implement different data balancing techniques. So for this, we are going to take a data set known as customer churn, which shows us, or we can say we have to check that measure why customers are leaving a business. So we are going to make a prediction model on that based on logistic regression algorithm. And we'll check that what is the data imbalance in this data set, and how are we going to solve this problem, and what are the results of some popular data balancing techniques on this data set. So let's get started. I have written some code from before, and I will be implementing just the techniques. So let me show you the code first. So I'm just importing some. I have imported some important libraries, Python libraries, and I'm working on Jupyter Notebook on VS Code. So I have and I'm reading a data set in a data frame, uh, referred as DF. So customer.churn.csv. This is our CSV file, the whole data set, raw data set, we can say. So we are getting this file, and when we are doing the value count, so we can see the number of no and number of yes. The difference is very high between these classes, and eventually we are going to make our prediction model on the base of that only. So if this is the difference and this remains there, then our model would not be cannot properly predict that the customers are why the customers are actually leaving, and it would not be able to predict it accurately. The accuracy will not be there. So further, we are dropping some irrelevant columns and checking the data types and all. And further we are going, and see, if you see the if we see the shape of the data frame, we see the huge imbalance factor. Like there are 7,043 to 20 ratio. So it's a huge ratio. It is a huge difference. So going further, and now that data set, basically data to know our data, that what are the important classes, and what are the different frequencies, and what are the different patterns that we can get. So after that, now, what we do when we see yes and no, we are changing it or zero, so that to calculate and classify also. So uh, we are changing the yes to one and no to zeros. Further, so let's go further. Now we are going to do the train test split, splitting the data. Right, now training values. Now if we see closely, then the value for the zeros is 4,130, and the value for one is 1495. So we can see the huge difference between the two classes, and this is not going to give us a good prediction model in order to calculate the values further, like precisely. So there would be a huge difference in precision. So we are going to check this after making our model also. So we have made a model. Hmm. So on the basis of logistic regression, I have written this function, and yes, on running this function, a model is created on the basis of logistic regression, and it predicts some values, and the values are. Okay, so and the values are here. Yes. So basically, what we see, the precision in F1 score, and the difference you can see is that the precision for 0th class is 0.88, and for the 1 is 0.60, and similar for the F score. So there is a huge difference between the F1 score of 0 class and the F1 score of 1 class. So our main motive is to reduce this difference and maintain the accuracy as well. The goal. So now I have shown you the data set and shown you the training model and shown you the difference between the F1 score and the precision. So now we are going to balance the data, this imbalanced data sets. So the method one would be undersampling. This is a very famous method. I've explained it in the video also. So let us continue with that. So we are going to make a class. So basically what we are going to do here is that we are going to undersample the majority, and